So in this video, we will learn how to integrate trigonometric functions. So here we have sine to the power of m, which could be any integer x, and multiplied by cosine to the power of n, which could be any integer x dx. So there are three cases that you can have. The first case is that m, the power of sine, is odd, and n, the power of cosine, could be odd or even. So for that it doesn't matter. And here we will use the Pythagorean theorem, which is that sine squared x plus cosine squared x is equal to 1, and specifically we will rearrange the equation to sine squared x is equal to 1 minus cosine squared x, and this is the formula that we'll be using if we have this case over here. Now the second case is that m is going to be even and n here is going to be odd. So here we will be using the same formula, sine squared plus cosine squared x is equal to 1, except that we are going to rearrange the equation in terms of cosine squared x is equal to 1 minus sine squared x. And I can give some examples for the first case and the second case before going ahead. So here we could have example of integral of sine to the power of 3 x multiplied by cosine to the power of 2x dx, or this could be 3. So it could be 2 or 3, doesn't matter, it's odd or even. And for this one you get the idea, don't need to explain this, it's pretty basic stuff. Now the third case that we can have is that, so this is the case that m and n are both even, so n is also even, and here we will be using the half angle identity, which is as follows. So sine squared x is equal to 1 over cosine x, 2x over 2, and cosine squared x is equal to 1 plus cosine 2x over 2, and these are the two half angle identities. Now the main thing in half an identity formula, angle identity, is that you are halving the angle from before. So here we have sine to the power of 2x, and the angle of cosine becomes 2x. Now let's say if you had sine squared 2x, what do you think the angle of cosine here will be? It will be cosine 4x. So keep that in mind. Always half the angle whenever you're using the formula. Now some more things that you need to remember are the basic integrals. So integral of sine x dx is negative cosine x plus c. The integral of cosine x dx is equal to sine x plus c, and secant squared x dx is equal to tan x plus c. Next one is secant tan dx is equal to secant x plus c, and these two are not used that much, but it's you still need to remember them in case. So the integral of tan x is equal to ln secant x absolute value plus c, and the integral of secant x dx is equal to ln secant plus tan x plus c. So these are some integrals that you need to remember in order to do integration with trigonometric functions. So now let's start with some examples. So let's say we have the integral of sine cube x multiplied by cosine squared x dx. So our first question that comes in our mind is that why can't we just use u substitution? So if we chose u as cosine x, the we will cancel one of the derivative of cosine is sine, so we'll cancel one of the sines, but there will still be sine squared left. Now if we chose sine as our u, the derivative of sine is negative cosine, and that will cancel one of the cosines, but there will still be one left. So that is why we cannot use u substitution. So that's why we need to go back to our three cases that we mentioned before, and we realize the power of sine here is 3. So here m is going to be 3, which is odd, and n, the power of cosine, is 2, which means that it is even. So which of our cases mentions that m is odd and n is even? If we go back up, it is the first case, and we need to use the equation of sine squared x is equal to 1 minus cosine squared x. So we can write that down. So now we can break the sine cube into, let me make more space here. We can write this as sine squared x into sine squared, sine only, into cosine squared x dx. And we can replace sine squared with 1 minus cosine. 1 minus cosine, don't forget to use brackets, and multiplied by sine x multiplied by cosine squared x. So what do you now think we should take u as, such that it cancels out something over here? So we can take u as cosine x, and du will be equal to negative sine x dx. So now we notice that we will be able to cancel the sign over here. So now all we need to do is substitute u as cosine. So it's going to be 1 minus u squared, as u is cosine, into sine x into u squared, and dx now is going to be, let's rearrange this and rewrite it. It's going to be equal to du over negative sine x. So it's going to be du over negative sine x. So this sign will cancel out with this, and we can distribute the negative sign over into this bracket since it's multiplying. So basically it's 1 minus u squared brackets multiplied by negative 1. So it's going to be equal to u squared minus 1 into u squared du. And now we just simplify this out, and we will get the integration of u to the power of 4 minus u squared du, and we know how to integrate this now. So u5 over 5 minus u3 over 3 plus c. Now let's go back and substitute u back into whatever u was. It was cosine x, so it's going to be equal to cosine to the power of 5x over 5 minus cosine 3x over 3 plus c. And one more thing to keep in mind is that you need to choose your u very be careful what you choose u as, since if you chose u here as sine x, we will be left with, we won't be able to simplify this equation. So we always pick u as cosine, since we had an extra sign here and we had to cancel this out using du over dx and whatever now. So that's why. Let's do more examples and it will be more easier to understand. So let's move on to our next question, which is integration of cosine to the power of 5x dx. So what do you think, which case should be this one? So first of all, we can notice that we don't even have a sign here in this question. So what this basically means is that we have sine to the power of 0 x multiplied by cosine to the power of 5x dx. This is another way of thinking about it, since we do have a sign, but it's to the power of 0 basically, if we want to use one of the cases. So here, back to our three cases, m is going to be equal to 0 and n is equal to 5. So we need to use our second case, And the formula that we're going to use is cosine squared x is equal to 1 minus sine squared x. And here we can break down cosine to the power of 5x into, I'm going to ignore the sine to the power of 0 here. So this will become integration of cosine to the power of 2 into cosine to the power of 2, and we have one extra cosine left, times cosine x, and we can replace this part and this part by 1 minus sine squared here. Hopefully that is clear. So it's going to be 1 minus sine squared x into 1 minus sine squared x into cosine x. So now think about this. So what do you think u should be such that, it cancels out cosine over here? So u here is going to be sine x sine x, and du is going to be cosine x dx. And here we can rearrange and rewrite it in terms of dx. So it's going to be dx is equal to du over cosine x here, and this part is going to cancel out, so cosine is going to cancel out. Let's rearrange it. It's going to be 1 minus u squared into 1 minus u squared into cosine x, and dx here is du over cosine x, so this part just cancels out. I can just write here du. So now it's pretty simple. We just need to multiply this and integrate this. So now we need to expand the brackets. It will be equal to integration of 1 times 1 is 1, 1 times negative u squared, then negative u squared minus 1, then be another u squared minus u squared, and this is going to be plus u to the power of 4. So we can arrange this and write 2u2 plus u to the power of 4 here du, and now we know how to integrate this. So it's going to become u minus 2u3 over 3 plus u5 over 5 plus c. We can add the c at the end. And now the last step which is left is to substitute what we took u as. So it was sine x. It's going to be sine x minus 2 sine 3 power x over 3 plus sine to the power of 5x over 5 plus c. So this is the final answer. It's pretty simple. So our next question is integration of sine squared x into cosine to the power of 4x dx. So what is our m and n? The power of sine here is m, which is 2 and it is even, and here n is going to be 4, that's also even. So here we are going to use the half angle identity, which is our third case, which is sine squared x is equal to 1 minus cosine 2x over 2, and cosine squared x is equal to 1 plus cosine 2x over 2. And you need to remember both of these, and the main thing is that the angle gets multiplied by 2, if you notice that. So now let's rewrite the question in terms of the simplifications, the half angles I mean. So it's going to be integration of sine squared is going to be 1 minus cosine 2x over 2 into cosine squared is 1 plus cosine 2x over 2 squared. Actually, I'm going to expand the last one also and rewrite it in terms of what it is. So it's going to be 1 plus cosine 2x over 2. Now I need you guys to remember some basic formulas, which are the perfect square formula. A plus b is squared is equal to a squared plus 2ab plus b squared, And the other formula that you must remember is that the difference of square, so a minus b into a plus b is equal to a squared minus b squared, and this is called difference of perfect squares or squares, not sure. So here we notice that we have to times these 3 times, so we can take 1 over 8 outside. If you notice, that is half into half into half, that's going to be half cube, and we can take that outside. So 1 over 8 integration of, now we notice, oh, I removed the perfect square formula. A squared minus b squared. So we notice that we have 1 minus cosine 2x into 1 plus cosine 2x, which is this formula over here. So we can write this part in as a squared, which is going to be 1 squared minus cosine squared 2x. Now the last brackets which is left is this one, so I'm going to multiply this by 1 plus cosine 2x dx. So here we simplify the equation into, we just distribute and multiply here, so it's going to be 1 plus cosine 2x minus cosine squared x 2x, and minus cosine cube 2x dx. So here now I'm going to separate each of these integrals and do them separately. So what is the integration of 1? This is x, right? What is the integration of cosine 2x? Is going to be sine 2x over 2. So now for these two parts I'm going to do them separately. So what do you think the integration of cosine 2x squared, cosine squared 2x is dx? Here m, the power of sine, is 0 and n here is 2. So here we again need to use the half angle identity. So the half angle was, this is equal to integration of 1 plus cosine 4x. Don't forget this, we need to multiply whatever angle we have into 2. So if we have let's say cosine squared x, the half angle will become 1 plus cosine 2x. Here we have cosine squared 2x, so the half angle will become 4x over 2. So let's say we had cosine squared 10x. What do you think the half angle would be? It's going to be 20x, right, over 2. Let's say we have actually a cosine squared half x. What would be the angle of cosine in the half angle? It's going to be this multiplied by 2, and that will give us x here. So that's one important thing to keep in mind. Now we can move on. So now I'm going to take the half outside the integral, so it's going to become half integral of 1 plus cosine 4x, and here we can just simplify directly. So it is going to be, if we go to write dx here, it's going to be x plus sine 4x over 4. Since we take the derivative of the angle and it divides it, we can expand this and keep the final answer as half into sine to the power of 4 sine 4x over 8. And let's now move on to the next integral, which is cosine cube 2x. And remember that I did not take the sign here of the negative, and not even here. So here again, what is m here? M is going to be 0 and n here is 3, right? So here we are going to use the first case. So we can rewrite this cosine cube into, I'm going to do it directly this time. It's going to be cosine squared, which is 1 minus sine squared, 2x, don't forget the angle, multiplied by cosine 2x dx. Now we can take u as our sine 2x, since we can cancel out the cosine 2x over here. So u here is going to be sine 2x, du is going to be 2 cosine 2x. Don't forget that we need to take the derivative of the angle and multiply it. If we are integrating, we divide the derivative of the angle, and when we are deriving, we multiply it. Dx. Now we can rearrange this and rewrite it in terms of dx, so it's going to become dx is equal to 2 cosine. Actually, a simpler thing is that we can just take this to the other side and leave dx over here actually. So dx is equal to du over 2 cosine 2x. Now we can go back to our equation and rewrite it now. So it's equal to 1 minus u squared into, this is going to cancel out now, and we will have a half left, so I'm going to take it outside. And if you guys don't see that, I can write it right now. So we had cosine 2x and then dx, and dx is du over 2 cosine 2x. This cancelled out here. We can take the 2 outside here and be left with du over here only. So half is here. Now we can just integrate this, so it will give us half into u over minus u3 over 3, and this will be simplified to what was u sine 2x. So it's going to be equal to 1 over 2 sine 2x minus sine cube 2x over 3. And now we can plug in all the values from our main integral. So it's going to be 1 over 8, and this is x. Cosine 2x is sine 2x over 2 minus cosine squared 2x was our this part over here, so half x plus sine 4x over 8. So I'm going to open brackets and write it here. Half x 1x over 2 plus sine 4x over 8. Let me just recheck that. Yeah. And this part over here that we just did was half sine 2x. Okay, so half sine 2x minus sine cube 2x over 6 minus sine cube 2x over 6. And actually I'm gonna switch these brackets so it becomes more clear. Yeah, so now we can notice that this minus half sine 2x can cancel out with this part, so these two parts cancel out. So I'm gonna clear some space here and write the thing now. So it's gonna be 1 over 8 open brackets x minus half x is gonna be x over 2. Moving on, so it's gonna be minus sine 4x over 8. I'm just distributing the minus sign over here and bringing sine 4x over here over 8, and here is gonna become plus sine cube 2x over 6. And the final thing, don't forget, is the plus c, and you can leave it as this form, it's perfectly fine, or you can find the common denominator and factor it and blah blah blah, but this form is also correct. So yeah, that's it. So as always, I do have a shortcut method for you guys to recheck your final answer on your calculator. So let's go back to the original question. We have integration of whatever this is, and you first of all need a calculator with the integration function. So you just type your question and you can put any two random numbers here. Most probably, I mean preferably it should be 0 or 1, because 0 later on it will help you. I'll show you why. So let's just put 0 and 1 and you will get some answer as 0.08998. And one other thing that I forgot to mention is that you need to convert your angle to radian instead of degrees here, since this is because you will recheck your answer later onwards. So change your calculator to radians and put any two values as 0 and 1, the lower limit and the upper limit, and in your final answer in this part you are gonna substitute x as 1 first, the upper limit minus the lower limit of 0. And now you see why 0 will help, because this entire thing will be 0. So all you need to do here is just substitute x as 1 and here also as 1 and here so on, and you will get the exact same answer, which was 0.089988. So this really helps you recheck your answer if you have extra time in the exam. And I will be making a short video to show you guys, of course, since it's more easier to make a video and show you guys, of course. And thanks for watching.